Alright, this is June 2007, Module 2, AS2. And this is question 1. I'm just going to make it a little bit bigger. A wave is travelling through a medium. With reference to the movement of the particles in the medium, distinguish between a longitudinal and a transverse wave. So, again, this is a very common question, and we've met it before. So, a longitudinal wave, the particles vibrate parallel to the direction of travel of the waves. Whereas in a transverse wave, the particles vibrate perpendicular. And those are just definitions that you must learn of. Part B, derive the relationship between the velocity v of a wave, its frequency f, and its wavelength lambda. So we start off with velocity or speed is distance over time. And in a time period, in one time period, wave travels a distance of 1 lambda. So v is equal to lambda over t, but t is equal to 1 over f. So that's equal to lambda over 1 over f. And when you divide by a fraction, it's the same as multiplying it by it upside down, and that gives you lambda f. So v is equal to lambda f. And again, that's something that you just have to learn off, a derivation that you have to know. During the period of the manned moon landings in 1969, communication between NASA and the Apollo command modules was maintained using microwaves. To which wave types, longitudinal or transverse, do such waves belong? So, we know that microwaves are part of the EM spectrum, and they're all transverse waves. State one property of the microwaves which was essential for their use in this way, and the main property was that they could travel through a vacuum. An instruction was sent from NASA to the command module when it was 2.38 by 10 to the 10 metres from their surface. How long did it take the message to receive? Did the message take to reach the command module? And so we know, first of all, that they travel at the speed of light, which is 3 by 10 to the 8. And you've got a distance, and so we're looking for a time. Therefore, you're going to use speed as distance over time. So velocity is distance over time. And we're looking for time, so we'll rearrange that. Time is distance over velocity, which is 2.38 by 10 to the 8 over 3 by 10 to the 8. And so the answer there is 0.793 seconds. And you would expect that it would be a short time, so less than 1 second. Less than 1 second sounds just about right.